Hi guys, today I'll show you GroundingDINO, a latest state-of-art zero-shot object detection algorithm, how you can implement step by step on PyCharm. So before going into the implementation, we just need to know what is GroundingDINO and how it's work. Basically, GroundingDINO is a self-supervised zero-shot object detection algorithm and which can detect object from a text prompt. So what is text prompt? Basically text prompt may be either it's string or list. So this GroundingDINO can detect object from the string or it can detect object from the list. So now we'll know what is list and what is string and how we can detect from this. Let's see with an example. Detect object from the string. Here you can see a person with a laptop. If I send this prompt and an image to this algorithm, then this GroundingDINO algorithm will detect a person with laptop or something like coins on the table, or we can detect multiple objects from the string like this: mouse, pen, tissue boxes. Like this we can send the string and image to this GroundingDINO algorithm and it will detect the bounding boxes accordingly. And another way, from the list we can detect object. Here we can send the text prompt as a list. Basically it is a Python list. In this way we can send mouse, pen, wallet, this list of classes into the algorithm and image. Then GroundingDINO algorithm will detect the bounding boxes if it is found on this image. So in this way, basically GroundingDINO detect object from the image. So step by step I will show you. First I will show you detection from the string and then I will show you the object detection from the list. So let's get started. First you need to clone the GroundingDINO from Git. For this we need to copy this line and paste it to PyCharm terminal. After clone, a GroundingDINO folder will be created under the object detection. Here you can see the GroundingDINO folder after cloning from the Git, and here you will see the requirements.txt file. Here you need torch vision, supervision, these all packages to install. So you can use pip to install all of these. First we will install the torch version 1.12.1. You can see here I have already installed, that's why it shows requirements already satisfied. Then we'll install the torch vision and it's version 0.13.1. I have already installed all of this package, that's why it's showing requirements already satisfied. And then we'll install the supervision. Supervision is basically used for visualization, like matplotlib, but it's very fantastic. So you should install 0.6.0 version. Now we'll move to the GroundingDINO folder, and here you can see the requirements.txt and setup.py files. So now just we need to execute this command. I'll give this all the commands in the description box in my video. Just you need to copy and paste it here. Then we have to create the Python file main.py, and first of all under the GroundingDINO folder we need to create this main.py. First of all, we'll import load model and load image, predict and annotate. Then we need to import supervision. So first we try to load the GroundingDINO model. So for doing this, we need to first show the model config path. So from where we can get this model config path, I will show you later. I am assigning here config path variable and checkpoint path variable. Checkpoint is basically the model OS. This is the variable. Now we need to assign this config path and the checkpoint path. So inside the GroundingDINO, you see a folder config. Inside this, you can see the last one, Swinty. We need to assign this file path inside the config path variable. So you just need to copy it and paste it here. Then one thing is remind the checkpoint path. Checkpoint path basically is the model weight. To assign this, first we need to download the checkpoint. We need to get the weight. So the checkpoint path is basically the model weight, and we need to download it. For getting this weight, we need to just execute a command. Before that, we need to create a folder inside the GroundingDINO directory, weights. Inside this directory, we'll download the model weight. So we need to move inside the weights, and then here you can see the nothing is showing here. So we just need to execute this command. I will give all this command in my video description box. You can use it. So in this way, where the model weight will be downloaded inside the weight folder. Now you can see the model weight, and we need to copy this path. I need to assign checkpoint path variable. So basically, loading the GroundingDINO model, we need to assign two variable, config path and the checkpoint path. So if it is okay, we can get output from the print model. Hopefully everything is okay. Yeah. This is the basically the model structure. So we have successfully load this model. Now I need to create another directory for image, and this image will send to this model for the object detection. Here we import an image. This basically, this image is captured from a mobile, and we can assign image path variable here, and we can copy this path and paste it here. Now we need to assign some variable. Basically this variable we need to pass through the model for the prediction or detecting the object. Basically GroundingDINO model detect the object based on the text prompt. So here the text prompt is mouse, and we need to assign also the box threshold and the text threshold. Now we need to basically load the image from the image path, and then we need to send this image to the model. Basically this model will return bounding boxes of the detected object and the accuracy and the object name. Object name is basically the text prompt it will return. If it is found, it will return the text prompt as a object name. So here is model. We can change this name to my GroundingDINO model. And then the image will send to the model for prediction or detecting the object. Then basically you can change it to my image. Then it looks good. The caption is the text prompt. Then the box threshold is the box threshold, and the text threshold. All of these parameters we need to assign to predict the bounding boxes. Here you can see maybe there is some issues inside the image. First we can check it's working or not. If we get the print result, then it's okay. Maybe there is some issue. Okay, let's check. Yeah, we're getting error. So you can basically load image will return to value. That's why it was showing some issues there. Hopefully it will be okay. This predict function will predict the bounding boxes of the mouse from this image. So let's check. We're getting torts not compiled with CUDA enabled. Actually, this is the big problem. All of you are facing this problem to run this GroundingDINO. So here I will show you a simple way to solve this problem. Here you can see the utils directory, and inside this you can see a inference.py. Here you need to find the predict function. inside the predict function, you can see here the device is CUDA. That's where you are basically getting this error torch not compiled with CUDA enabled. Just we need to, as you are running on in CPU, there is no CUDA and node GPU is here, so we need to change this CUDA to CPU. Let's check again. Yes, it's changed to CPU. The device should be CPU because we are running in my PC and here is no GPU. Let's check. Hopefully it will be solved and detect the mouse from the image. We got it. We got two bounding boxes here and two mouses, and these two predictions percentage. Now basically we need to annotate the image first, then we need to display. For display image we need to use supervision. So import supervision as SV. Just we can write here sv.plot image. So basically we need to plot annotated image, otherwise we don't understand. So before display we need to annotate, and this already we imported. So annotated image, annotate. Here you can see the image source. We can find it from the load image. Yes, just copy it and paste it here, and then the boxes, in the boxes we can change detected boxes. It seems looks good and it will not conflict. Then logit equal to accuracy, and for checking the annotated is working or not, we can just print the annotated image dot shape. There is some issues. We need to, we miss here the and object name. Basically this the object name, the detected object name. So let's check, hopefully it will work. Yeah, we get the image shape. That means annotation is successful. Then we need to display using the supervision. So you need to put it here, the annotated image, and the size. Let's check. Basically it will detect mouse. Yeah, we got it. Here you can see two mouse on the table. Accuracy is very good, 82%, and here another mouse with accuracy 76%. So in this way, basically GroundingDINO detect the object based on the text prompt. Now we can check the bounding boxes accuracy and object name individually. Uh, basically this three parameter returns from the predict. Now you can check, yeah, we got two bounding boxes, accuracy and the object name. So it's working very fine. Basically GroundingDINO is very fantastic object detection algorithm. Now you can check the wallet. Yeah, we got it with 58% accuracy. GroundingDINO is a zero-shot object detection algorithm. We can detect multiple objects based on the text prompt. Wallet, mouse and tissue box. Let's check. Yes, we got it. It's working very nicely. It's really amazing. Tissue boxes with 68% accuracy. So in this way we can change different things and we can detect based on the text prompt. Now you can add the person and also you can add the water pot and we can add the keyboard. Let's check. Wow, that's great. It detect the water pot, keyboard. Two keyboard is here, you can see, and here's the water pot person. Successfully detected all of this object based on this text prompt. We can use language like text like person with laptop. Then what will happen? It will return basically two bounding boxes, I think. Yeah, person with laptop and the person, two bounding boxes. So it's really fantastic. In this way we can detect a person with laptop. Now we can detect coin on the table. Basically inside the GroundingDINO the clip language model is working. Here you can see the table and the coins on the table. Really amazing. Now we can check only the coins. Then what will happen? Nice. It detect all of these three coins very nicely. Now we'll detect floor from this image and it will return a bounding box. Really fantastic. We got the bounding boxes from the floor. Now you can sense it to ties. Then what will happen? Then I think it will detect separate tiles from the floor. Yeah, we got two tiles, two separate tiles and two separate bounding boxes for these tiles. Actually, I think we never see this type of detection algorithm before. Now we'll check power cable on the table. Let's check. Wow. On the table, we see the power cables and it detects nicely and really fantastic. Now we can check the pin on the table. Actually, I put it lot of things on the table for the detections. Nicely detect pin with 74% accuracy. And here is the surprising matter. Another pin is detected under the keyboard and with 51% accuracy. It's very nice. Now I'll show you in another way. From the list we can detect object. For that we need to create another file. Basically we'll detect from the list. Just we need to copy this file to another file and we'll load model in different way. I will show you. It will detect object from the list, Python list. It can detect object. For that we need to go RoboFlow, GroundingDINO, GitHub. From here we need to copy some, paste here. You need to just click on this link, annotated dataset. Yes, and here from here I'll copy some lines. Here you will also face some difficulties and I'll show you how we can overcome these difficulties. So we need to load the model first. Previously we use load model function, but here we'll use another command. Just model equal to model, and we need to also import this function. First we need to copy this model config path in the previous code and then need to delete this because we want to keep the model name mygd model as previous, and here we need to change this model. As you can see error, just we need to import this model, then yeah, it's gone. Some little bit modification we need to done here, and we can copy it. Basically we will send this type of list to the model. Previously we detect from the text prompt like this, and now we'll send a list, basically Python list, classes name like mouse, wallet, and tissue box. Suppose this is a list of this is the list of classes, so we'll send this class to the model. So we need to read image here using cv2.imread. Then we need to import here cv2, and basically we need to delete it and need to copy the detect object, this code from this RoboFlow GitHub, paste it here and we need to delete the previous one. You can delete it. In the previous file, we use my image. Here we also use my image, and we need to just copy. So here is the test threshold. We need to copy this, because inside the direction you see the class enhance class name, this function inside the direction. Basically in the list it will add all, like all mouse, all tissue boxes, like this. So here you can see the classes. This classes actually will send this function enhance class name, and it will return with some additional text here. So the detection function is now okay. Now we will print this detections. If it is okay, here we use predict, but here we use predict with classes. Basically we are pushing a list of classes, and based on this model will detect the object. From here we need to copy this for annotation, and we remove it and paste it here. So we're getting some error here. Just we need to change the image frame here, and another error. Here you can see the image. Basically it will be my image. Yeah, the error gone. Now we can check it out. Oh, we're getting the same error, torch not compiled with CUDA. Now we need, as we import this model from the GroundingDINO, we need to change again from the utils inference file. Here you can see the class model, and here we need to change the device. Here you can see the CUDA. As we are running it on CPU, that's why we need to change this to CPU. As we don't have the CPU here, hope it will solve the problem. Let's check. Oh, nice. But we got an error here. We got 4 bounding boxes, but we got an error. Here basically this is the big issue on RoboFlow GitHub code. We need to change something here. Basically detection returns 4 parameters, but here in RoboFlow we can see 5 parameters. That's why we're getting this error. expected 5, I've got 4. Basically it's return 4 parameters: 1, 2, class ID, and 3 and 4. 4 parameters is written, but in overflow code we see 5, so we need to change here. Let's check first. Either it's 4 or 5. Let's check. For ABCD in detections, just we'll print it here. If we got it, let's check. Level, there is no issue. Getting an error, but it's no issue. Let's check. Hope yeah, it's working. We got separate 4 bounding boxes and 4 parameters in each loop, so we need to change in the row flow code. Hope it will solve this previous problem. But first is the bounding boxes, then second is the confidence. So here we can write boxes, second is the confidence, and third is the class ID. Hope it will solve the issue. Here you can see in row flow code, maybe here is some mistake over there. Let's check it again. Now to delete these lines and let's check. Hope it will solve the issue. Yeah, we got it. Basically in this time we send a classes list of classes, Python list, to the function predict with classes, and we successfully got 4 bounding boxes here. So in this way, basically GroundingDINO detect object from the text prompt and from the list of classes. We can change this list and check. We can add here person, water pot, and keyboard. So let's check. Actually this is the list of classes, Python list. We send with predict with classes function, and it will return the detected bounding boxes from this list. Yeah, we got it. We got the water pot, mouse, person, keyboard, tissue box. So it's really fantastic. In this two way we can detect object using GroundingDINO. One is from the text prompt and another is from the list. So it's really fantastic. Hope you understand clearly.